Hello. Welcome back to this tutorials. Let's continue our journey developing this interactive terrain. And I would like to say that today's lesson will be quite complicated because instead of we writing new code, we'll be adjusting old code. And don't be afraid to pause the video and actually to look at your code, because even I writing this code, I missed few variables, and it caused me an additional few hours actually to debug and find these issues. What exactly we're addressing today will be the update function, which one is looping every frame. And instead of we sending one per terrain paint request, we will be grouping all the terrain paint requests from the same tile. We'll do additional calculations to get the area, which one this multiple paint requests are. So we need to find the min max of X and Y. And additionally for that, then we need to change all this function, which one is paint texture, our main function. And we need to change it in regards of passing list instead of one terrain paint request. So let's jump in. So let's start from writing new variables. First of all, because we have already a list, we need another list. Of terrain paint requests. Which one we can call like a current paint as terrain requests. And let's create in the memory. So this list, which one is different from a terrain request queue, it's a current terrain request. So we will be grouping all the terrains in a new list, which will be the same tile. So we'll take the first from a bucket. We'll take the first terrain request. We'll look at its terrain ID, and we will find all other ones from all other terrain paint requests from the rest of the list. We group in the new one list and we call it current terrain requests. Additionally, as I mentioned before, we need to find, well, not find, we need to hold and save its integers, which one will represent IDs in the list. And to do that one, let's call them a map request ID. There's 4 letters, AMRID. It stands for alpha map request ID. And we want, actually, I can copy this one. And I want min X, max X, and min Y, comma, max Y. And why we need all this for 4 IDs. Oh, sorry. So let's assuming this is our terrain, and the red is one terrain request. When we have a green is another terrain request, and we have a third terrain request. So we have 3 terrain requests to paint it, and yeah, they can be different sizes as I just draw, because it could be, this could be a person, this could be a carrot, carriage. This could be, I don't know, maybe the cow because it's a bit more rectangle instead of square shape. So before, when we have alpha map, this is all alpha map. When we had a one request, we know the alpha map pixel we're requesting to get, and we know width, height and width for that one particular request. Now, the step number one, we need to get this alpha map. Well, I can actually use that one. We need to get this alpha map request in yellow as a yellow box. And to do that, we need to find the x, the y, and the y. So the minimum x, maximum y, and the minimum y. We need to find all this for coordinations in alpha map. That's pixels, not unity coordinations. Well, but why we care about IDs? They're really simple, because we need to know which ID of the terrain request actually is the furthest in the X left side, which one is the furthest in the X side, etc., etc. So in this case, let's give the IDs to our paint request. If this green is 0, this is a 1, and this is a 2. So I know that the minimum X will be ID 2. The maximum X will be 1. The maximum Y would be 2. And the minimum Y will be 1. So by knowing this IDs, I can look at this terrain paint requests and get the rest details, like paint size, fade size, and so on and so on. If I just get the size of pixels and losing IDs, I will lose another additional data like paint size or fade size, or even the strength it need to be painted. So that's why we'll be working with IDs. And here we have this alpha map request ID max X, max Y, min X. Yes, all four. Second step, we don't need this one anymore. But TPF first in the queue. I know we just created last lesson, but we don't need anymore of this one. So what we need to do now is actually to update this one. Okay, no need this. Yes, first of all, the current terrain requests we need to clear. Then you have a list, and to clear the list, you have two options. Either way, you can delete, or you can identify as new. Both is valid, and some of them they have different use cases depending on the data you have inside and so on. This won't be a huge data inside. I'm talking about maybe 10 requests per tile. It depends on your game, of course, but in this case, I'll be using a second option. The list is equal to the new list. So that means that wherever it was previously in that list, it's lost. By lost, what it means, it's still in the memory, but we lose the reference. The current terrain request will be a new list in which one is a terrain request as well. By new, it means we'll be allocating new memory location, and we give a new address, and we give a reference, which one called current terrain request. Previous list lost its reference, and the garbage collector in a few frames will be removing it. So, as I said, it has pros and cons, but it's it's still valid. Still valid and good to go option. Additionally, what I love with this option is when we create the new list, we can actually insert the first member. And by doing to do this one, you start with the curly braces, and you just you say what you want to do. So because we already checked in the line 46, we checked that terrain request queue is count is greater than 0. So we definitely have at least one request. So what we do, the current terrain request, we definitely will put the first terrain array request queue 0. We put the first member from our all terrain requests. We put as a first member in current requests. So we have already one. What we need to do now is we actually remove. Let's remove at. And for some reason it doesn't like me. Yeah, that's it. So what we've done now is, okay, we take the first in the list, we save in the new list, and we took out from that list. So it's no more the first member in our all terrain requests. Now we'll use for each approach. Well, we'll say the terrain requests. Terrain paint request TPR in terrain paint request queue. What we will do, so we loop each member in that list. Well, don't forget that list is already one. It has one less request because we just removed one. So if it was only one, all this will be skipped. If you have a 2, it will be do once because the first one is already gone. So in Unity, and I think in general in C#, not sure, but I'm most familiar with the Unity itself. So if you wanted to compare two vector 2s, you can't do this. Like if current terrain request, the first member, yes, and terrain ID is equal to TPR terrain ID. You cannot do that. To compare two vectors, you need a special syntax. You can't just use an operator. Well, at least didn't work for me. So what I find, what I'm using, it's called dot equal, and you put a second vector into brackets. So you write the first vector to, which one, terrain ID is a vector to int, dot equals, and you put a second vector to int inside of the brackets. This will return true or false if they are equal. You can use operator equals, and especially when you're talking about a vector-free position, which one is a float, and because it has decimal point, that operator in Unity actually rounds up a bit numbers and actually it gives you true and false ish. If the two objects are close enough to each other, it gives you true, if not false. Yeah, please read in the Unity documentation if you're seeking more details about that one. But for this case, and most of games when I use equals, and that only works if the two numbers are same. So be aware of vector-free float numbers. They have so many decimal point, and if one number is different, like 0.000001, in Unity it's not equal. So be aware of that. So if they are equal and the terrain request, terrain first member, terrain ID is equal to any of another terrain member in the request queue, what we want to do is to add it. Yes, I tried to now write and remove TPR from a terrain request, but it didn't work that one. You can't remove terrain TPR variable from a that list because it's in that list. So you're looping, you can't remove it. So what you need to do, you do again for each terrain paint request. We call again TPR in this time in current terrain requests. So now what we do, we actually loop from each member terrain request, which one we just build it. We find all terrain requests with the same IDs. And what we're doing is we're saying terrain request queue remove. And we're saying what we remove TPR. So all the members we find is the same tile. We remove from the main terrain request queue. And yeah, well, next this will be quite interesting. So what we want to do now is actually to pass current terrain requests. And of course, this will give error because it's expecting a single variable and we're passing list. So what we do is we just scroll here, be prepared for that one, because when we type list, it will generate loads of errors. Before we diving in this all problems we just generated, we need to change one variable as well. A private vector to int a map position. It's a single, but we actually would like to do and hold them as array. We should not to state how big size of array we want, because this size will be different from request to request. Some of tiles will have only one request. Some of tiles will maybe have 10 requests. So what we do is we go back here. And by taking terrain as a list, we'll be start chipping one problem at a time. So let's have a look in the notes. Next following step. Yes. So first of all, when we have a list, we just gather all the terrain paint requests. Now we know how many of them we have. So we say new vector to int, and the size will be tpr.count. So the map position requests, which one we need and how many we need, is the same how many tpr terrain paint requests we find it. So alpha maps position amount, same as TPR requests. So now we need to loop for every single one, and we need index. So for, we'll be using for this time. Int index is equal to 0 as long as index is less than tpr.count index plus plus. And we put all this inside. So if tpr at index is not overlap, we send in here tpr with index and comma index. So we want to pass to this function two things. First of all, we want to pass the tpr index and index itself. And why we're using this index, we'll return. I'll come back to this later because all this function is here. I just want to finish this for loop first, and then we discuss why we need this index to pass to the function. So here we're saying index as well. And we need to, well, actually copy. We need to put index here. We need to put index here, 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 and one more Additionally, we need to say that a map position at index is equal TPR at index O position. That's it. And of course, it's a debug log a map position. Well, we don't need this time. It's from previous lesson. So now what is left is this function. So this function is only taking variable TPR. We giving TPR alongside comma integer of index. So let's first change parameters we take in this function. So int index. And what we need to do with this one? So we just add here. So by doing this, if you look here, so we have TPR, which one is T, P, oh, sorry, P, R. And this TPR is number 2. By doing this, we have another a map position, a map pos, and they are identical. So we create one list, which one is dynamic size of TPR, and we create a map positions of arrays, which one is fixed size, and is the same size of TPR. But one of the key points you need to remember that the index for both lists, well, list and array is same. So if I address any member in that list, number 1, for a map position and TPR, it's same. Why it's important? Important because we have a number, let's say we have a number 0 as a map position, alpha map position. So because it's pixels, we have alpha map. We know where is a 0 index a map, terrain request. Now we need to know how big this request is. To do that one, we address a member in TPR as well 0 because they are equal. So a map has a position in the alpha map. TPR have the size of the square. And both they are linked. And they are linked because we just use the same index everywhere. By reading TPR at index, we saving all the details at alpha map index. So they are linked because we're holding the same index. Moving forward, for a map request, so a map request is this yellow box. To do that, we need to find min x, max y, and min y. And for that, we need a function. Let's do a function in the end. Somewhere here. Private. It will return nothing. And it will be called find underscore a alpha map request ID. Yes. We'll take no variables and let's open this one. So to find something like this, it's what's the technique it's called? I don't know the name of technique, but we need the variables which one can hold this value. So we need integer for max x, which one will be a negative 1025. Well, again, this number should not be a number, it should be a variable, and this should match your size of terrain. So I'll leave it comment. Your size of alpha map. Your size of alpha map. Yeah, your size of alpha map plus 1. In my case, my alpha map is 1024. Plus 1 means I definitely definitely it will be a greater. It will be definitely greater than that one. So, and why it's a negative 1025? Because I'm looking the greatest number. I want to make sure that any number, any possible number which one can fall down will be the greatest one. So what I mean, if someone will decide to, for some reason, to set the paint size equal to the terrain itself, you want to paint a whole terrain tile, which one is 1024. So that means that if you stand on the edge, you have if you're standing in the edge, your terrain request it's negative 1024, and that is the highest because it's only one terrain request. So being on the safe side, you plus one. In other words, any number, any terrain request we possibly can get now will be always higher than this. And opposite. Oh, we should start from min x OCD. Let's start. So yeah, min x. Well, no, let's leave it this one here. Int min x. Vice versa, min x should to be 1025. And the reason is now because any number we getting ever in this case, min x will be always lower than this number. It's possible to get 1024, which one is lower, but it's not possible to get 1025 or higher. So then, because I'm looking the lowest number can be 1024. So I need to start looking from something above 1025. Same applies for min y and max y. Okay. What we do now is we should loop through all our for, and we'll tick, and we need again index. We'll be using this index equals 0. As long as index is less than a map pos dot length index plus plus. Now we start doing checking. If a map pos at index, we're looking for a min x. So if a map position dot x is less than our min x, and in this case, any number here always will be lower. It will be lower, but it's only the first member in our list. So if this is lower, so we're saying min x. Now min x is equal to a map position at index dot x. So this number is always will be lowest than 1025 at the first time. So it will be always low. Let's say min x in our case. Let's assume first member it's if it's 1024. This is a bit. Let's say it's a half. It's a half, yeah. So 512. Yeah. So min x becomes 512. Okay, because we just saved here. Next member comes. Next member is blue, and the blue is about, let's say, I don't know, 650. Let's assume 650. Is 650 less than our previous number? No. And then there's another number. Another member comes. Which one is about 300? Is this lower? Yes. And we saved again. And we keep looping until until we find the lowest one. But when every single time we find the lowest one, we want to save that ID. We want to save the member's ID, which is lowest. So alpha map request ID min x is equal index. So every single time we find, this was a blue, we find a 0. Sorry, green, we saved and lowest is 0. Then we checked blue, no, it's still 0. When we check red and we find, okay, forget about blue, forget about 0. Now new member, which one holds the lowest x number, it's member with ID 2. Okay. Same applies for rest. Oh. Jesus Christ, what's happened? Same applies for all of them. So if map x is greater than max x, we won't save that one. And save here as well. Replicate for y. And the max y is greater than. Cool. And that's it would be for our finding approach. Simple, checking, running. Of course, you can save this integers outside of a function to keep the same memory, but this is so small calculation, which one it should not take any, and it take out any performance. I'm just looking, did I forget anything? No. Let's go. Okay. Let's go back. So we finish up before request map. So what we want to do is to call that function before we asking for that yellow box. A function was called find underscore. It liked it. Find array. Did I paste in the wrong? Okay. I don't know why it was not suggesting, but find AMR ID. After we find all of this min and max, we can adjust this a map request. And a map request, as I mentioned it, it's that yellow box. Okay. Yeah. And this will be a quite complicated one. I think we can. Okay, let's cut into 2 pieces. First of all, it will be. It's separated by comma. Let's leave a comma somewhere. Here. So between this one. Between X and Y. So, how to explain this approach? We're talking about this yellow box. Let's delete some. we need to give some, I think we need to give some, I like this ones. Yeah, I think we need to give some coordinations. So let's assume this is 300 and because 1000, I just wanted to stick with really simple numbers. Let's say this is 800 and this is square. Yep, so 800 and y. Okay, so and we find that number 2 is the lowest, our min x. So we need to send a map request of its location. Now we need to send of, yes, x here. And the lowest of y, it's 1. And we need to get this number. Did I explain it correctly? 800, 800, yeah, 3 by 300, so 300 and 300. So we'll take x coordination from number 2, and we'll take y coordination from number 1, because number 1 is lowest minimum y coordination holder. Let's delete this one. Let's start really simple. MS request. No, sorry, it's not coordinations. No. A map request is the size of, Jesus Christ, I done wrong. So a map request is a size of this yellow box. So how we need to do is actually to take the lowest min x, so it will be number 2, and we need to subtract the highest x, which one is number 1, by 800, subtracting 300, we still not confirm because the number 1 is here. It's at bottom left corner. Yes? We need to add this box length to find the full, to find this position. So by saying location of, it won't be 800. Number 1 location is 790 plus box size, so box, which one is 10, it makes 800. Which one is number we're looking for? And then we subtract the box red. Why the box red? We don't need to add any like box size because it's already the left corner. This will be applicable the same for y as well, because y is here and x is here, so it will be opposite. We will be subtracting from box number 2. We'll be subtracting box number 2 plus box size, subtract box 1. Don't forget, additional to this box size, we have paint size and fade size multiplied by 2. And this is really simple. So alpha map position of AMR ID max x. And the max x is blue box, 790. We need to add the box size. And the box size, what we have is plus TPR. TPR at AMR ID max x. So because we're using the same ID for both of them, they match AMAP position and TPR with the same ID. They are the same request. We have TPR dot paint size plus brackets TPR at AMR ID max x dot fade size multiplied by 2. And all this should go inside brackets and minus and minus a map position. Let's look at our drawings. And we need to subtract now 300, which one is a red one. And the red one we indicate as we indicate it as a map request ID min x. Oh yeah, forgot one thing. We're talking about .x and .x. Int and vector to int. Oh yeah, pane size.x. I forgot about that one because we care only about the box, because it could be not square, it could be a rectangle. So we care about x box size because we're counting this sideway. So, and that's it. That will be comma, and we need to repeat one more time here. Leave it one bracket. And we start similar. A map position of AMR ID max y dot y plus TPR at AMR ID max y dot pane size dot y this time, because we care about the box. We care about box size. Which one is here? Goes up. Plus bracket TPR at, not at, TPR, which one is in array, AMR ID max y. Oh, press AMR ID max y dot fade size multiply by 2. And all this we need to put in a bracket. And now subtract by a map position of a map request ID min y dot y. Here we go. So this is how we calculate. Actually, this comma can go. Yep. So this is how we calculate this new yellow box in a map, using this pixel coordination, adding our terrain pane sizes and the fade sizes multiplied by 2, and we get this box. Now we need to do some checking, and we checking about if any of this request actually gets, if any of this request actually is, let's say this blue box is on the edge of terrain. You see, because now its original position is here, but terrain request is overlapping, and we need to fix all this. So it will be really quick copy paste. I can even zoom a bit more for you, like do 200. Nah, 180. 180% was good. I hope so you can see clearly. So which of the AMAP positions X could be lower than 0? That's really simple to answer. Only a map request ID min X. Only this member could be lower than X. Well, actually, when I said it, I thought about if two members actually isn't on the edge, but this possibility really low. Huh. I'll try to address this one in the next lesson, because by saying this one that only this member can actually be a lower than 0 on one tile, or vice versa, is in another one. Let's assume we have one more terrain request. Which one is, I don't know, color pink. He is as well overlapping. So we have now two requests. Which ones are overlapping? It won't be crashing. It just, this terrain request won't be executed because we only checking against one. And we should check against all of them. So to fix it, this one is really quick. Copy this one and keep adding everywhere. Have a look into my map. Yep. Oh, this is really important. Now, instead of a map request is this, what we actually need to do is just to change that a map request.x is minus equal different. So, because let's say this, let's forget about pink one. So the difference, we find the different that we are 10 pixels in another one. So what we want to do, this yellow box, is to decrease by, to decrease by 10. So this yellow line will be matching with this line because we overlapping 10. Previously, we know that it will be different. That's just a different. But now we want just to decrease by 10. Here we want to do the same. And overlap is TPR here. So everywhere you're seeing this red line, you just need to add area AMRID min X. And double checking here. Still same. Oh, I added it in the wrong place. Z. I need to add after TPR. Ignore that first line gets in the red because it's again about overloaded constructor. So we have two different constructors, and compiler doesn't know which one we're trying to use. So first member gets in red, but it will get back as soon as we will fix all these members. Voila. Here it's a bit different story. We will be using alpha map request ID max x. Copy it and we paste. And here, same as previously, minus equal different. Oh, wrong place. Okay. We need to repeat the same for y, and I will be speeding up. Okay. Something is missing. Okay, now I'll try to put on everything on the screen so we can actually pause and look if everything is missing. This is x less than x and greater than x. And here is for y. Okay. So you don't have any errors or any wiggly red lines. Try to look your code and see what's happening. Sometimes it's just one letter or something. So now we need to adjust our IMAP, alpha map. So this yellow box, because we know already the size of yellow box, only one thing is what's left is to find location of this corner. So in our example, we know that it's a 500 length by 500 length, and it starts at 300. So terrain ID, because all these terrains request is from the same terrain ID. So what we can just say that the first member terrain ID X and the first member terrain ID Y. And we can say that all ID is the same. So if we're saying it's a first member, the rest of them is from the same ID. Get alpha map. So X and Y. And for that one, it will be AMRID min X. And it will be AMRID min Y. And if you look in this map, we'll get 300 from a red one, and we get 300 from a blue one. Following that one, we need the size, and size is already calculated, so no problems. Okay, only 2 steps left. We need to update this for loop. I think it's most difficult one, and we just need to adjust this final line, and all will be done for today. So because we won't be dealing with only one request, we need this nested for loop to nested to another for loop. We'll call index is equal 0 as long as index is less than alpha map positions. How many alpha maps positions we have? Dot length. Nice. Index plus plus. And we took the curly braces, we delete that one, and we just add one more here. Nice. So what we don't leave this. Oh yeah, we change a bit this one. So it's no more a 0. It is y should to be y should to be a map position at index dot y, because we just read all this yellow area, and it has small pixels, and it has small here. So what we want, we don't want it to start looking for y is equal 0, because y is equal 0 is here. What we want to do is we get this for first our member. So y is here, and we want to keep increasing. And so y is equal imap position dot x. As long as y is less than, not all yellow box, as long as y is less than. So first of all, we need to find the position. So the finding the position is only just a map Yes. So this pixel is 359, but it's only 59 in this yellow box. So how we can find that this location is 59? And it's really simple. We take 359, which one is, we know its position. We subtract the lowest number, which one is 300, and we find out that it's 59. And to do that one, as long as y is less than a map position at index dot y, so 359, we subtract a map position at AMRID min y, sorry. We subtract 300, and what are we getting? We're getting 59. Now we want to do is we need to add the number of this size. So we just find this one. Now we need to add this box size. TPR at index dot pane size dot y plus, oh yes, I don't want to complicate this one. So every loop, before even starting this loops, let's create vector to int, we call, I don't know, TPR size. It will be general size. We keep it, yes? And when we start looping, let's say this TPR size is equal to TPR at index dot pane size plus TPR at index dot fade size multiplied by 2. And we can't do that one. Can we? Yeah, we can't. So we're saying a new vector to int bracket and bracket, and we copy all this, copy paste, comma paste. And now what we do is pane size dot x and pane size dot y. So now we just made calculations for TPR size, and because we start looping here, it will be different for each request. So in other words, it will be different, driven by this request sizes. So the blue box will be the bigger, then red one, etc., etc., etc. And why I'm doing this one is just simplifies this, because now we need to copy all half of that one in here. But instead of that one, because we already doing calculations, we simplify this a lot. And we just say TPR size dot y. And we're missing here dot y as well, aren't we? Yeah. That's it. We need to repeat the same here. A map position at index dot x, and as long as x is less than a map position at index dot x minus a map position a map position, what I'm looking for. Oh yeah, AMRID min x dot x plus tpr size dot x. Done. What we're looking here now is just copy square brackets index. We just need to paste here. For after each TPR. And TPR index, TPR index. Done. The last small bit. As I mentioned before, terrain IDs is all the same for all of them. So we can take just a first member in the list as our request. And X and Y should to be lowest one. So we're saying a AMR min X and AMR ID min Y. Save it. Control Shift build. Let's test it. What I changed, by the way, in this for this tutorial, I remove a grass because it was a bit difficult to see all progress with a grass around. I add and spread a bit more all the destinations. It's across 4. Yes, yeah, it's across 4 different terrains. Additional to that one, I enabled all our gentlemen. And let's see how it progresses. So we have some errors. One of the things which one I forgot about is additional to all this, as y is less than our Vista TPR. Oh, we need to add and y is less as a map request dot y. So in other words, if we have a cube like this, which one, I think we done paint a pink one. Yeah. If a pink one is outside of a yellow request because it's a side of terrain. We don't want to have any looping outside. Anything what is outside of our terrain, it will be overlap terrain request and we send to another tile to paint. In this tile, we want to make sure that y never goes more than we actually requested. And it's the same here for x as well. X is less than a map. Sorry, capital A map request dot x. Save, build. Okay, and we still have some errors. Let's have a look what kind of errors we have. Okay. Scroll on the top. Argument is outside. Let's have a look. Oh, yeah. Okay. Okay, this is from previous one. So we no need to remove because we already removed all of them. Oh, yeah. Oh, yes, delete that one. Okay. So, okay, so far two errors I found. One, it's in the function find AMRIDs. By accident, I left here min y. It must be changed to max y. Additionally to this, where we have overlap calculations, and especially for y-axis, this line was different. So change to minus equaled different. And another addition, which one we need to change, it's y is not equal the map index.y, but we need to subtract the number. So if we go back to this example, if we want to find this number and it's 359, we need to subtract the lowest number, and we will find out that from here up to here, this is 59. So 359 minus 300. And in our case, it's 359 minus 30. For x, it's similar. Minus a map position at amrid min x. Of course, dot x. Let's test again. I'm testing with only one person. Yes. Nice. We have painting. Okay. Now for a final testing, let's clear this one. For a final hour testing, I was using, by the way, I was using this code of line for a testing. It's pure commented, but because I write down for myself, I can actually address and I know which one numbers what. Meaning, what I'm trying to say is, it's only the numbers. If you look in console, it's just 5 numbers. But because I know each number meaning, all these 5 numbers is really helpful for me for testing. Let's comment out, save. Let's get back to our project. Let's zoom a bit out. Let's put all our gentlemen. And let's go. Yeah, and of course they have all different what's called. They have all different values to painted. Nice. Finally, let's stop this one. Let's look how it looks in a game. Still, you will be seeing that it still has a performance issues, and it drops down. One of the reasons because all of them start at the same time. All of them has same speed. So apparently, what's happening is that all this requests will come up at the same time, and they will be executed literally frame after frame. So we have about maybe 5. Well, let's think. We have 4 tiles on which where all this gentleman is walking. So we'll have 4 inconsistent frames doing all this what's called terrain updates, and they will happen 4 frames in sequence. And we can feel it when we even would try to scroll the map. We start seeing that it's actually frame drops. On a corner, even though we have FPS 130, which one sounds decent, and it's really decent, we still have a minimum of 30. So we have this what's called the whole of the FPS, the really drop down of FPS, and we have 4 frames. If our gentlemen will walk in different speeds, or they started in different ratio, or something else happened, this number, we won't be seeing this FPS drop. But I wanted to take the most, I wanted to take the worst case scenario, and try to optimize this case. And if we are able to optimize for a worse scenario, case scenario, then we're not afraid to release this game and, you know, not falling down as cyberpunk. Sorry. Okay, thanks for your time and see you soon. And